So now we've just installed the probes on the positioners, and we close the shield environment. The next step for us is planarize the probes, because they may be slightly off of the horizontal position, and we need to adjust it, make sure that all contacts, the ground signal, ground contact, they are in place and parallel to this probing area. So how do we do it? First of all, we move our accelerator check, so the calibration substrate, to the empty area where we have some gold material. We use as a ruler or for probe planarization as well. It's kind of a double purpose. All right, next step is I have my probes in the shadow, and I'm currently on the separation height. Means that if I hit the button contact, nothing going to happen, because the contact separation height is 250 micron. It's more than enough. So I go to the contact. This microscope follows. Now my accelerator check is in contact height, and my probes are somewhere above. I can bring one of the probe down and double check what is the contact footprint, and if I need any planarization actions. So let us start moving the right hand side probe down. So we are getting closer, closer, and closer. We clearly see the contact tips, and we just need to bring the probe in contact very carefully and observe the very first forward skate. So for the Titan probes, you see it right away, and what we can see here is that the three footprints of the Titan probe, ground, signal, ground. So they're very well aligned, and it looks like we don't need any further planarization for the right hand side probe, because all the footprints are very similar, very identical to each other. So leave the probe up. And I'm going to repeat the similar experiment for the left hand side probe. So go back to contact height again, and bringing the probe down in Z, it's very close. Forward skate, leave the probe up, move it a little bit aside, and again it's a new probe, and we have three marks which are very identical, very small, and planar to each other. So there is no need to any further probe planarization. All right, on the closed view of the probe arm from MPI micropositioner, we can see supporting marks which help us for the initial planarization of the probe. So there is one reference mark on the probe arm itself, and the three are the orientation marks which are placed on the mechanical feed through of the probe arm. What we can see here right now is that so the central mark as well as the location mark or reference mark, they're perfectly aligned to each other, which means that the position of probe arm is in a parallel position against the chuck surface. We just proved the probe on it, and this is the new probe, and also the new probe has extremely small error in its planarization versus the holding area of the probe body, and we've just observed it in our footprint test that we don't actually need to do any further probe planarization. This is a very good example how the probe marks embedded on the probe arm of MPI positioner help you to drastically reduce the time required for the initial probe setup. We install the probes, we planarize the probes. The next step for us is to double check alignment of the calibration substrate. and make sure that when we move from one calibration standard to another calibration standard, we can hit the target accurately. So that's one of the major requirements for the accurate and repeatable measurement results of calibration substrate, calibration standards, and repeatable calibration. So Santio has a special tool that is responsible to operate with calibration substrates. We call it Auxiliary Chat Navigator. So using this tool, we can teach Santio for a position of a particular calibration substrate, not only X and Y position, but also the contact height, and special information about what type of the calibration substrate is resting there, and what is the local home, and so on. Let me walk you through the initial alignment process. So on the Santio dashboard, we see that we are currently over the auxiliary chuck, and let me switch to auxiliary site module and start the initial setup procedure. So on an initial setup procedure, the first screen helps us to define where we are going to set up our calibration process. And what you see here is that we currently have two auxiliary chucks available for RF calibration on the system, auxiliary left 1 and auxiliary left 2. Auxiliary left 2 is empty, currently empty, and we also can set up calibration process for on-wafer calibration standards. That is the very first selection out of this through. Because we are already at the auxiliary chuck, left 1, so the first step for us is we select this location and we would like to set it up for the RF cal. So as long as we selected this action, so this auxiliary chuck, graphical user interface, or say the wizard, brings us to the first definition, so where we can do a different setups. There are two different ways of configuring auxiliary chuck here, either for RF calibration process or for the probe cleaning. We want to calibrate our probe, so this is RF calibration process. So at the next step, we select a type of the calibration substrate which is currently resting on an auxiliary chuck. And out of all database records which we see here on this list, this is the all calibration substrates from MPI, from GGB, from some other vendors, which are already available in the database of Calibria. We set up a calibration substrate which is AC2V2 from MPI. This is the one which I currently have here on the system. Define its ID, and definition of ID is important because Santio also tracks the number of touchdowns of a particular calibration substrate, and I will show you how it works a little bit later. So after we defined, we selected calibration substrate type, we know the ID is correct, we move to the next step. So the next step, the graphical user interface is automatically switched to the big window, which is showing us, this is the vision, which is, gives us the whole overview of the current location of the calibration substrate. And our first step is to set up contact height. After we finish the definition of the contact height, we can do other exercises. So the step number 1, we move the chuck to the desired contact height location, and we set up the contact height here. So the system just brought me a dialog mentioning that I previously set up another contact height on the main chuck. So I clear it because we will be operating RF probes here, changing the probing location. So I will need to reset the contact height of the main chuck later on. So we define the contact height here, and we move to the next step. The next step is the theta alignment of the calibration substrate chuck, automatically drop down to the separation, and we can move to any regular structure for us and do a 2-point alignment over the long distance or a quick align over the short distance. Let me show you the alignment over the long distance. I will select one of the transmission lines over the top and point and shoot. Navigation here. This is my reference point for the point number 1. Then we move to the other end of the calibration substrate where we have a similar structure. They are located on the line. So, and do a little bit of minor adjustment and set up the reference point too. Now the theta angle is redefined, so the substrate is aligned and we can move from one element to another. So the next step is the set home. With the next step of the alignment wizard, we define the home location, which can be arbitrary. There are different ways to define the home position, and some people prefer using substrate embedded alignment mark here to be the home element. Some people prefer using either open or a load standard for that. My personal preference, I usually define the local home over the load standard. As I said, it could be an arbitrary position. It's just a preference of a system operator and maybe some initial rules set up in a particular laboratory. So let us set up, select this element. Yeah, that is the location which I would like to use as the home. And during this location, I also move the chuck to the contact, and I bring my probes into the contact on this home element. So I start with the right hand side probe, bringing closer to the focus, to the location, the target location. You can do it with the with Titan probes from MPI, because with the Titan probes you can clearly see the point of the physical contact and electrical contact. So let me slightly move the scope, adjust it. That is my desired location. I go back to the auxiliary chuck. I'm in contact, and now I bring the probes, the port 2 probe in contact. It was a little bit too much. Bring it closer to the center of the pad. And the Titan probe requires from 5 to 7 micron over travel on gold, which means that if I land the probe in the center position of the probe pad area and observe just initial forward skate, this is already enough for good and reliable contact. So let me repeat a similar exercise for the port 1 probe. Bring it to the focus, adjustment in X and Y. Bring to the Z. So getting very close. So we want to bring probes at the middle of the standard pad and make sure that we have an over travel of about 5 micron. Yeah, the probe starts slightly moving. So this is enough, and this is the good probe adjustment. So we set up local home. We brought the probes into the contact, and now the last step for us is to select our home element, which is currently, we don't know where we are, right? So let us enable the view of the microscope and the check where we are currently located. Which standard is it? We are in the middle, so let us count the number of the standards. So this is 1. So we should be here. So this is the one element which we use as our home element, and we have a little bit of home mark which shows us this element is selected now is our local home. And by doing this, we finish the procedure, and now we are able to use the calibration standards for the entire calibration process.